Hello, my good friends. I am very happy to have you here with me. I know the main reason why you click on this video is because you have a need, and the need you have has to do with Neco practical on chemistry. And I'm going to give you some possible questions on what you likely going to see in your Neco exam. After you have done your titration, the next thing that you should do is to calculate the average volume. But before that, I need to help you to understand how to present your table. Look at it as I do it gradually. We will have pipette volume used is 25 centimeter cube. Your school might be using 20 centimeter cube, but I believe that most schools are using 25 centimeter cube. Then you also need to indicate the indicator. That's give them the indicator. The indicator can be methyl orange or it can also be phenolphthalein. Therefore, be careful with what the instruction is. If they say you should make use of methyl orange, make sure you use methyl orange. If they say you should use phenolphthalein, make sure you use phenolphthalein. And the next thing to go is to write all burette readings are in centimeter cube. Okay, now what you are trying to do here is that you are trying to let the examiner that everything you're going to do, even if you make mistake of not writing the centimeter cube, the examiner should understand that you have already given this information prior before the table itself. Yet we can still include it in the burette reading. Please, I will only make use of this table in different calculations I'm going to make in this video. Therefore, keep this calculation close to you. Although on the screen I have it, they're kept very well. Okay, let's look at the table. Notice that I inserted my CMQ here in all of them, and you should also do the same when you are doing yours. This is the initial readings. You can have different values here. Therefore, 22.30 minus 0.00 will give us. I know you will be wondering how I managed to have 22.30 without mistake. It's not manipulation, it's actually a work done. From here, the next thing we are going to do is to calculate the average volume of solution A used. And the formula for it is first titer plus second titer plus third titer all over 3 will give you the average volume. And if we substitute the values, we are going to have which will give us 22.30. That's our average volume. Now we can actually treat some questions that is going to work with this our value 22.30. But based on theoretical calculation, the answer of our average volume should have been 23.2. But because of it is not all that possible to have a perfect titration in exam, and WAEC and Neco bodies, they are always interested to know who is actually manipulating values. Therefore, you should be careful in your manipulations of value. Make sure you do the practical, but follow the lead of your teacher giving you his or her own endpoint. For instance, today my endpoint is 22.30 centimeter cube, and it does not actually mean that is what your school is going to give you. Maybe the chemical your teacher is using might be very much better than what I am using, but make sure that you follow your teacher. As I say that your teacher is the #1 person, but here you are only watching this to have a exposition of how your questions will look like, how these practical questions will look like, so that you will not have fear in your writing of Neco. Now let's look at some possible questions they can actually ask us in this Neco. A is a solution of sodium hydrogen tetraoxosulfate 6 salt containing 12.75 gram per dm cube. B is a solution of impure sodium hydroxide containing 3.95 grams per dm cube. Using average volume of acid to be 22.30 as we have gotten from the table. Then they are asking you to calculate concentration of A in mole per dm cube, concentration of B in mole per dm cube, percentage purity of sodium hydroxide in B. And you should understand that sodium is 23, hydrogen is 1, sulfur is 32, and oxygen is 16. What I mean there is their molar mass. And the equation of the reaction is as shown on the screen. Therefore, we go with the solution. We should look at what is being given to us. Therefore, let's go for the given. We have here concentration of solution A in grams per dm cube, which is going to give us 12.75 gram per dm cube. Also, we have concentration of solution B impure, that is the impure concentration of solution B in gram per dm cube. We will have it as 3.95. The volume of the base is 25. We take the volume of the base here to be VB, and that of the acid to be 22.30. That is the average volume used. If you look closely to the equation itself, you notice that the mole ratio between the acid and base there is still 1:1. Therefore, Na and Nb is all 1. Therefore, Na and Nb are all 1. But we are not giving concentration in mole of solution A, concentration in mole of solution B. Therefore, possibly, that is what we are going to look for. And if you check from the question, they asked us question 1 to find the concentration of A in mole per dm cube. That's the first to treat. We should know that mass concentration is the same as molar concentration times molar mass. But we're supposed to know that sodium hydrogen tetrodosulfate acid molar mass is 120 gram per mole. Then our molar concentration will be 12.75 all over 120.0, which we have the answer as 0.10625 mole per dm cube. And this number is more than 3 significant figure, and most times Neco and WAEC actually expect you to leave this answer in 3 significant figure. Therefore, leaving it to 3 significant figure, this is where the answer is supposed to end, and the value that is close to it is not up to 5. Therefore, we ignore these 2 and 5. We take it as 0.106 mole per dm cube. That's to 3 significant figure. The second question asks us to calculate the concentration of B in mole per dm cube. Now, we have gotten Ca, we have also gotten Va, we also know Vb, we know Na, Nb, but we don't know Cb, and that is what they asked us to get here. Therefore, we are going to make use of the formula CAVA. If we make Cb the subject formula, we will have, and if we substitute the values, we will have, which will give us, leaving the answer to 3 significant figure, we will have. The next thing they ask us to look for is to calculate the percentage of purity of solution B. Now we go to calculate for percentage purity. It is gotten by the mass concentration of the pure sample all over mass concentration of the impure sample multiplied by 100%. That whatever we have there is going to be that. But we don't have the mass concentration of the pure sample, but we only know the molar concentration, which is 0.0946. So the molar mass of sodium hydroxide is 40. That is, sodium is 23, oxygen is 16, and hydrogen is 1. Join them together gives 40 gram per mole. Therefore, we're going to get the mass concentration of pure sample, which is, but previously they told us the mass concentration of the impure sample is 3.95 grams per dm cube. Therefore, we go percentage purity equal to mass conc of pure sample all over mass concentration of impure sample multiplied by 100%. Inserting the values, we have 3.784 all over 3.950 times 100 all over 1, which will give us 95.7974683. But we need to leave our answers in 3 significant figures. So we will have 95.8%. Mind you, the units are very, very important. You don't just do without it. You make use of it always, because making use of it will show that you actually know what you are calculating and you know what you are doing. The units are very, very important because it's all about measurement. Now, if you look at this answer, 95% pure, it means that the impurity must be there. There is an impure substance present in the sodium hydroxide. And what can actually be this impurity? The impurity might be as a result of absorption of water and carbon 4 oxide from the air. As the teacher is trying to measure the sodium hydroxide, since it is a deliquescent substance, you should understand that it's a deliquescent substance. Therefore, there is no way the teacher will be all that accurate to make a titration that's going to give you 23.2, and that is just the truth, because of there must be absorption, except if that place is well airtight, which is not that possible. Therefore, the answer giving you 95.8% is trying to prove that it's possible that there is absorption of water, which make the weight of that particular sodium hydroxide to be measured to be higher, and was included as sodium hydroxide, which might not be actually only sodium hydroxide. Let's look at another question. A is a solution of sodium hydrogen tetraoxosulfate 6. B is a solution containing 2.0 gram of sodium hydroxide in 500 centimeter cube. We are still making use of the average volume to be 22.30 centimeter cube. Then you are being asked to calculate the concentration of B in mole per dm cube, concentration of A in mole per dm cube, and concentration of A in gram per dm cube. And note that your hydrogen is 1, oxygen is 16, sodium is 23, sulfur is 32, and the equation of the reaction is shown at the same time on the screen. Therefore, we need to go with what has been given to us. The volume of the solution A used, which is VA, is being given to us as 22.30. Volume of the solution B used, which is our VB, is 25.00 centimeter cube. And we know that the number of mole ratio of solution A and B are all just 1. Therefore, we are going to have CA and CV is not given. Therefore, we go back to the question. The question asks us to find the concentration of B. Therefore, we are going to look for this. And we have already information that will help us to get that. That's 2.0 gram of sodium hydroxide in 500 centimeter cube. Converting 500 centimeter cube to dm cube, you're going to have it as 0.5. That is 5,000. That is 500 all over 1,000 will give you 0.5. So we have the mass concentration of solution B to be, which gives us the answer. So what we are going to do now is to convert the solution B from mass concentration to molar concentration. We are going to have mass concentration all over molar mass. Now our mass concentration is 4 gram per dm cube, but the molar mass of solution B, which is sodium hydroxide, is gotten by 23 plus 16 plus 1, which is going to give us 40. So we insert the values we will have. The answer is 0.1 mole per dm cube. You may be wondering, why do I insert this 00 when it is not actually important? No, because I'm working with 3 significant figures. That's why I still include this value, the 00s, even though it's not actually important. But for this place, it needs to be there for it to be in the 3 significant figure. Now let's go for the next question. The next question asks us to find the concentration of A in mole per dm cube. I believe you know that we already have CB, VB, NB, VA, and NA, but no CA. Therefore, we are going to make use of the CAVA all over CBVB equal to NA all over NB. Therefore, making CA the subject formula we will have. Inserting the values we will have, 1 times 0.1 times 25 all over 22.3 times 1, which will give us 0.112107623. Leaving the answer to 3 significant figure we will have. So we go for the third question. The third question asks us to calculate the concentration of A in gram per dm cube. Therefore, we record that mass concentration is equal to molar mass times molar concentration. And we know that the molar mass of sodium hydrogen tetraoxosulfate 6 can be gotten by adding sodium, hydrogen, sulfur, and oxygen, which is 23 plus 1 plus 32 plus 16 times 4, which will give you 120 gram per mole. Then our mass concentration becomes 120 times 0.112, which will give us 13.44 gram per dm cube. I believe if, for instance, you want to understand how titration is being done, you're supposed to click my previous video on Neco. You can see that on my YouTube, where you can see how titration is being done. And I believe with your teacher might have also given you that. And your major reason why you are here is not even because of the titration issue. You're more interested to be exposed to the type of question or type of things you're going to see in the exam. And I believe that I have given you 2 questions, and if you work with it, it just remain one. They might ask you something that has to do with water of crystallization, which I just have to give you over now and use it as the last question. If you have gotten this, I believe that with God's help, you are going to do very well in your exam. Look at this sample question. A is a solution containing 7.23 grams per 500 centimeter cube of sodium hydrogen tetraoxosulfate 6 Y hydrate, and B is a solution of 0.79 gram per 200 centimeter cube of sodium hydroxide. Put A into the burette and titrate it against the 5 centimeter portion of B using methyl rate as indicator. Repeat the titration to obtain consistent titer. Tabulate your readings and calculate the average volume. We have already gotten our average volume to be 22.30 centimeter cube. Therefore, from your result and information provided above, you are being asked to calculate the concentration of B in gram per dm cube, concentration of B in mole per dm cube, concentration of A in mole per dm cube, concentration of A in gram per dm cube, and also find the value of Y. It's actually this value of Y that I'm more interested to show you here than any other, because I believe the concentrations have been dealt with in the first and second question. Therefore, I will be a little bit fast in doing the question number 1, 2, 3, 4. But question number 5, I will go gradual. Concentration of B in gram per dm cube, we will have the 200 centimeter cube is being converted to dm cube. That is 200 all over 1000 will give us 0.2 dm cube. As usual, the mass concentration becomes, by calculator, we have 3.95 gram per dm cube. Question 2. We use the relationship between the molar concentration, mass concentration, and molar mass. Having the molar mass of sodium hydroxide to be 40, so we will have, starting the appropriate values we will have, which is to 3 significant figure, we will have the answer to be question number 3. We are asked to look for concentration of A. We are asked to find the concentration of A in mole per dm cube here, and we have already gotten the VA, NA, CB, VB, and NB except the CA. Therefore, using the CA, VA all over CB, VB equal to NA all over NB, we are going to make CA the subject formula, which the value is going to give us, leaving the answer in 3 significant figure, we will have it as, let's go for question number 4. In question number 4, we are being asked to find the concentration in mass per dm cube of solution A. And the molar mass of solution A is already 120, as you can see on the screen. So we go mass concentration, which gives us 12.36 gram per dm cube. The last question is to calculate the value of Y. Calculating the value of Y is more like getting the mass concentration of sodium hydrogen tetraoxosulfate 6 acid, subtracting it from mass concentration of sodium hydrogen tetraoxosulfate 6 Y hydrate, and divide it by the same mass concentration of sodium hydrogen tetraoxosulfate 6 Y hydrate. We equate it with water all over the hydrated salt. So from here, we are going to go, we have, this comes from the question, this also comes from the question. This is the 500 centimeter cube converted to dm cube. That is how we got this. Okay, now we already know our anhydrous salt mass concentration to be 12.36 gram per dm cube. So we are going to obey the values of we have. Oh, you may be asking how I got this 120. You know the salt is sodium hydrogen tetraoxosulfate 6 dots. This is only for the acidic salt, but this is the water of crystallization, which is Y. Therefore, I can also change this value to be cross multiplication. We will have, yes, hope you understand this. Therefore, if you open the bracket, we will have collect like terms. We have make Y the subject formula. You have the value of Y to be. So the value 2 is not up to 5, so you approximate it to the nearest whole number to be Y equals to 1. Actually wish you good luck for your Neco practical exam. Thank you very much for clicking on this video. My name is Chukwu A. Marcus. Don't forget to subscribe, like, comment, and share for your friends for them to be able to get better results in their Neco. One thing I want to let you to understand is that your teacher, your school teacher, is most important in this chemistry practice.